In this episode, we're going to be introducing test-driven development in Java. Hi, I'm Mark Bradley and welcome to Testing All the Things, a screencast in which we use live coding to demonstrate different types of testing tools and techniques. In this video, we're going to use strict test-driven development to implement a queue in Java. Let's look at the code. Whenever I'm working, I like to have my tests on the left-hand side of the screen and the implementation on the right-hand side of the screen. So I can see both the tests and the implementation code at the same time. Today we're going to implement a queue abstract data type. We're going to test drive out the functionality using very strict test-driven approach. We will write a test, we will watch it fail, we will write just enough code to make that test pass, and then we will move on to the next test. We will continue in this loop, adding refactoring in whilst we are green to ensure that our code is as tidy as it can be. Let's make a start on the first test. The first piece of functionality I want my queue class to have is to tell me whether it is empty or not. We'll create a new test. Is empty. Okay, so testing the isEmpty function. So we need an instance of our queue. So queue. We'll call it empty variable equals new queue. And now we need to write an assertion. So this is where we check that the instance of the queue empty is in the correct state we're expecting it to be in at this point. So we want to use assert true empty dot is empty. Okay, and that's our test set up. The next thing we do, taking a test-driven approach, is we run the tests and we watch it fail. Let's do that. Let's run all the tests in the queue test class. And we have a failure. So at the moment, our failure is that the method isEmpty doesn't exist. So all we're going to do is we're going to make that failure disappear. So we will make the isEmpty function. So go, create a function called isEmpty. It returns a boolean. Make it compile. You can make it return false. There we are. So if we go back and we rerun our tests, quickly tidy this up a bit. Yeah. So we can see our test has failed because of an assertion failure now. So we expected true, but we got false. This is because our isEmpty function returns a hard-coded false. At this point, the easiest way to make our test pass is to change our false to true. At the moment, all we know about our isEmpty function is it should return true. That's all of our understanding. So that, because we have a single test that says it returns true, then we just make it return true. It's the easiest way to make the test pass. It also shows our level of understanding of this function at this point in time. Run our tests. Our isEmpty test now passes. So this is a point where we could do some refactoring. Given we've only got one test and one very simple function, there's no refactoring we can do at this point. But let's move on to our next test. New test. So let's try and improve the naming, because the naming of our first test isn't particularly good. So non-empty set. Yes, non-empty set is not empty. Here we go. We can take our setup. We'll call this 1, because we're going to add one thing to it. 1.add. Now, to keep our implementation reasonably short, what we're going to do is our queue will be a queue of strings. So we will add red to our queue. And now we can write our assertion. Assert false 1 dot is empty. Now, in the previous round of running the tests, I let the test tell me that the function isEmpty didn't exist. I ran the tests. Another option you do have at this point is you could let your IDE tell you that things don't exist. So you could either run the tests and let the test tell you that add doesn't exist, or you can use the highlighting in your IDE if you want to highlight that a function doesn't exist. So that your IDE does the compilation errors, and then you use the tests to test for the expected behaviors. So let's do that for this one. So we'll create the add method. It doesn't return anything at the moment. It takes a string, and we will call that value. Our test code, our implementation code, should now compile and be runnable. So let's try running our tests again. Yep, so we can see our previous test is still passing, but our new test is failing, and it's probably failing exactly the way we expect it to fail. So we expected it to be false, but it's returning true. That's what we're expecting to happen, because we knew we've hard-coded true here. So if we were just concentrating on the next test passing, we could just flip this back to false, but then our existing test would start to fail. So we want to write the simplest amount of code, the smallest amount of code, to enable both tests to pass when the tests run. We can't use hard coding anymore, so we need to step up our implementation a bit. And the next simplest thing we could do is we could just hold a flag within our queue class. So we could do something like private boolean is empty. We can default it to true. A new one will be true, true, and we can return is empty. That will keep our first test passing, because that will just return true. So we can run that and just double check that our first test is still just in a passing state. It is, and we're still in that same failure state for our second test. So we can now flip the flag from true to false when add is called. So is empty equals false. Okay, so that's showing our level of understanding of is empty at the moment. Once you've added something to our queue, it is no longer empty. Okay, so we'll run our tests. And both tests are passing. So let's look at our implementation. We've added 2 tests. Our implementation is still reasonably small. There's nothing we can simplify at this point. In our test, there's no cleanup of the code that we could do on the the implementation side, but what I would do is do something like empty set is empty. There we go. Is empty. Just a little refactor to make my test name a little bit clearer of what I'm testing. Or we could, another way we could do it is just call this test empty set and non-empty set maybe. But at the moment I'm going to keep it like that. And what we're going to do is we're going to move on to the next piece of functionality in our queue. So we know that our empty function works. We know it returns a Boolean, which is two different states, empty state, non-empty state. So we have fully tested the isEmpty function at this point. So let's move on to the next piece of behavior I want to describe in our tests and design out using tests for our queue, and that is it should keep track of the number of elements in the queue. So we'll create a new test, empty set 0 size. Yeah. Or we can just call it empty set size. There we are. So we will copy our empty set. There we go. Now we want to do assert equals. So the expected thing comes when you're using assert equals. The expected value is the first value you provide. So we expect it to return 0 for empty dot size. Okay, there's our test now set up. Our IDE is telling us that the size function doesn't exist. So it'll be a compilation failure. So we'll let it solve that problem. And what we'll do is we'll say -1. Okay. Oh, that was bad. Hang on. Yes, no, that's right. Now I'll run the test, see if it fails. It should fail. And it does. We were expecting 0, but we got a -1. So we'll change the hard-coded return to 0, and we'll save that. Cool. That test is now passing, so we need to move on to continue to describe the behavior of our size function. So let's do new test. One set. Okay, so one set size. So we'll copy this line. And we will assert equals. Again, so we want the expected response, so that will be 1 for 1 dot size. And we run our test. Okay. So we expected 1, but we got 0. Now, at this point, what is the easiest way to make this test pass? Well, we know that if we've added something, it should be 1 at this point. So we could do something like if is empty, return 0, else we can return 1. That should make it pass. Let's run that. Okay, all our tests are passing. We're back to green. So let's look at an opportunity to refactor now. We haven't finished implementing the size function, but is there any refactoring we can do? So not really on the implementation side at this point. It's still reasonably straightforward and as clean as it can be. but there is now an opportunity to do some refactoring in the tests. So refactoring doesn't just have to be within the implementation side of life. You want to obviously keep your implementation as tidy and as nice as possible, but you also want to keep the tests as nice and as easy as possible to use. If someone's going to come in and fix a bug, or someone's going to come in and add some functionality to some existing code, if your tests are clean and readable, it makes it easier for people to come in and add things to some code. So whilst we were implementing the size functions, we did some copy pasting. So we've got some duplication now. We've got our empty set being instantiated in 1 and 2 tests, and our 1 set being instantiated and set up in 1 and 2 tests. So we've got this duplicate code. So there's an opportunity to tidy this up. And what we can do to do that is we can use the before each function. So if we do new setup function, so it's either setup or before each, this function gets run before each test gets run. So what will happen is just before this test gets run, the setup function gets run. Then when this finishes, this test will be run. So the setup function is run again, and then in between these two tests, the setup functions run again. So this gets, for each test that is run, the test class is in a clean state. So what we can do is we can say we'll have a private variable, which will be q, and we can create empty and 1. And then we can take this, move it into here, and just instantiate the empty variable. We can do the same for the 1. Take this off, align everything. Okay. Okay, so now we've got our setup. So we've got our variables at the top, a set called empty and a set called 1. Empty and 1 are instantiated and set up to the right size in our setup function, and then our tests become really small. We've got assert true that empty is empty, assert false that 1 is empty, assert equals 0 for empty size, and assert equals 1 for the 1 size. Okay, so our tests are now very neat, and because of the naming of our variables being really good, our tests, the expected behavior is very clear that a 1 set size is 1, an empty set size is 0, and so on. So that gives us that opportunity to kind of keep our tests really nice and clean, because we've used good naming. So good naming of variables, good naming of functions is just as important in the test code as it is in your implementation code. Okay, so that's our refactor done. So now is the time we run our tests. We've cleaned up the code. Let's just make sure the cleaning up works. And it does. Our tests all continue to pass. So we're now in a place where we can move on to continuing to implement our size function. So we can create a new test. We're going to do 2 set size. Spell correctly. There we go. Okay, so oh no, I just realised I've been calling it a set. We've been making a queue. So let's just fix that before we move on too far. Queue size, queue size, queue size, queue size. Luckily we haven't got into the details of differentiate a set from queue, so there we go. Okay, so we'll run that to make sure our refactor passed. I shouldn't have done it at this point because I'm adding a new test, but it was a mistake I wanted to fix as I realised. Queue 2 equals new queue 2 dot add red, duplicate, and blue. Okay, and cert equals 2 dot size. We run a test, see that it fails. It does fail. We were expecting 2, but we only got 1. And if we look over our implementation, the reason is because we're either going to return a hard-coded 0 on an empty set, or we're just going to return 1. So at this point, the information we store within our object doesn't give us the ability to count beyond 1. So we know 0 and 1, we can't go to 2, 3, 4, and so on. So we need to look at how we can keep track of that number. What we can do is we can add another field to our Q class that we can use to keep track of that value. So private int, we'll call it size, we'll default it to 0. Again, a brand new Q will have a size of 0. And then what we can do is we can change this to just do return size. Save that. And but we also need to increment our size when we add. Let's keep track of the size. So size plus plus. There we go. So as we add, we increment the size, so we're keeping track of the number of elements in the queue. Okay. So our queue is working quite nicely. All of our implementation is done. Okay. Now, we were in a green state, so we can look at options to refactor and clean up our code. Now, if we look at our implementation code, we've got three functions. We've got the isEmpty, add, and size. And we've got 2 fields, the isEmpty and the size. Now, at this point, because of what we were doing in our size function, where we're saying isEmpty return, if it's empty, we return 0, what we know, we have got some knowledge here that 0 also means that, so if the size is 0, then the set is empty. So we have the option now to remove some duplicate knowledge that we're storing within our set queue to keep our class tidier and easier to understand what's going on. We can remove our isEmpty flag field from our set, from our queue, because we know at this point that size is 0 equals also means that a queue is empty. And also by removing this makes our code slightly more robust internally, because at the moment we are tracking 2 flags which kind of give us the same amount of information. So if this is 0, then empty is true. If this is greater than 0, then empty is false. And what would happen is there'll be other functionality coming later where we'd have to decrement and flip the flag. And that adds complexity to our code, which doesn't need to be there, because we can just use our understanding of the size. So we're going to remove that, and here we will say size equals 0, and we can remove it from here. So we'll save that, run our tests. Oh, there's a typo. So should have spotted that. Size, try again. It builds. Where's the run? Here we go. Run the tests. Close annotations. There we are. Okay. So our tests are all passing, the behavior stays the same externally, but our code has become smaller, more concise, and less prone to bugs. Okay, now whilst we've been doing this, also I've been thinking about the fact that made my understanding of test-driven development kind of more solid was the realization that you're using your tests to design the code, and what you should see your tests as is they're the first consumer of your code. So if your tests start to become hard to write, then maybe your implementation is not correct. It's, you know, this test is becoming very difficult to write. I maybe need to look at splitting things out and stuff like that. The other thing about this is it's also a good way to kind of think about the design of your implementation. Think about the naming of variables, or think about the naming of functions, especially to the external interface, because I'm using here the queue exactly how I'd expect someone else to be using it. And one of the things I thought about was the language around add. You don't particularly add to a queue. The kind of the real world language would actually be something like join a queue. So we can take this join, this add function, and we can, at this point, because we're working in this new class, we're okay to change the interface at this point. So we'll do that here. So we can say we'll rename join, add to join. We join the queue instead of add to the queue. There we go. We'll run the tests, make sure everything passes. Okay, so that's not particularly a refactor, that's actually probably changing the design, but that's a design decision I'm making during the testing thing. I wanted to use join instead of add because it made the code represent the real world of queues, and the language kind of matched what kind of, so if someone came and saw a queue and you joined the queue, they kind of, even if they couldn't read code, they should understand what's going on. So our size functionality is now done. We can move on to our next test. And the next piece of functionality or behavior that I want to describe in my tests is the behavior of leaving the queue, of coming to the front of the queue and being served. So we shall create a new test. Okay. One queue serve. Oh, so at this point we want to take our queue of 1 and we want to serve someone. So as we call the serve function, we want that value to be returned. So we know that our 1 queue has a red in it. So we can say cert equals 1. Oh, no, sorry. Expected value was red. So cert equals red for 1 dot serve. Okay. So this function doesn't exist, so we'll make it exist. There we go. Okay, and now we need to think about all of the other expected behavior of our queue. So assert equals, we expect the size to be 0. We've removed everything from the set. Okay. So set so 1 dot size. So we've served that person, so she should no longer in the queue. So our size should be 0, and if our size is 0, we should expect it to be empty. So assert true for one.isEmpty. Now obviously, because of our before each, a test after this on 1 would still pass because we would reinstantiate the 1 instance and re-add red to it before each test is run. Okay, but there's our test running. So if we run our test, okay, so we've got a failure and it says we expect red and we actually got null. Okay, so this is the only failure we know about at this point. We know there are 2 more assertions coming, but they're not failing yet because our test stopped running at our first assertion failure. So we need to just fix this one thing in front of us. We can say return, make it nice and easy, red. Okay, and we save that. Okay, now we expected 0, but we actually got 1. So our size is at this point incorrect. So we also need to make the quickest change to implement to make this test pass. So we need our size to be 0. So size equals 0. There we are. Okay, and if we add that, okay, and our test is passing. That's great. Now we're on to the next step. We need to obviously make our serve function implement the full functionality of serving, not just kind of these hard-coded variable swapping and returning. So we will go to a new test. Okay, so we will say 2q serve one. Okay, we're just going to serve 1. So we'll take our 2q. Okay, so we'll take our assertion. So the queues are a first in, first out implementation. So we still expect red to be the first value when we serve, because that was the first person in. We added red first. So we do assert equals expect red 2 dot serve. Okay, and now we assert equals, so we expect the size to be 1. We've taken 1 from a 2q size. I keep saying set, that's fun. So this is 2 dot size. Okay, and we expect the queue to not be empty. Assert equals assert false, sorry. 2 dot is empty. Save. Okay, we'll run our test. Our test is failing. We look at it. So we skipped over the first assertion because it still passes. The first element of our queue is red in both occurrences, so our hard-coded red still works. Okay, but our second assertion, checking the size, is 1, is failing. So we expected 1, but we actually got 0. So our setting the size to 0 is no longer the correct implementation. We need to move towards a better implementation. And what we can do here is, instead of just setting it back down to empty, back down to 0, if we decrement the size as we serve people, then we should be in a place where we can return the right value. So let's run that now and see if our test passes. And it does. Okay, great. So we've got quite far in the implementation of our queue so far, and as yet we're not actually storing any of the values we've been given. All we're doing is we're keeping track of the size. So I think we need another test. But also we're in a position now where we want to, we could do some refactoring because we've got our 2 here and we've got our 2 here. So we can move this setup into our setup function, into our before each. So we can do comma 2, bring this in here, and just take off this. So it's using the class field. Okay, and then this can be deleted. So our tests have got, that's fine. A little bit smaller again. So what we're going to do is we're going to we'll do this refactor. Okay, instead of 1, we're just going to change this to be first. Okay, there we go. Now we have it. Okay, so now we're on to next test. So 2q serve second. Okay. So because of our for each, at this point when we enter this next test, our 2q has 2 elements back on it. It has red as the first element in the queue, and blue as the second element, and we want to serve that second element. So the first thing we need to do is we need to serve the red. So 2.serve. So that there is doing the same as our test above. It's serving the first customer. So now we need to do our assertions. We've tested this bit works here. We don't want to retest it, but what we now want to do is we want to do assert equals. So our second element in the queue is blue. So blue. 2.serve. Okay, and then we have this. So again, so we expect if we've served the second element, the last element in our queue, we expect the size to be 0 and our set to now be empty. Okay, let's run the test. Okay, yep. And as we expected, we were expecting blue, but we actually got red because of this hard-coded value here. So we now need to really start storing the values we're given in our queue. So we shall do that. So we're going to create something that can store it and keep things as simple as possible for now. So we'll do private array of strings elements equals new, oh, wrong way around. Right, can't type this morning. There we are. New equals new string array. And we'll set 10 for now. Save. Okay. So we've got something. It's very simple. We've got something to store our array, our queue elements in, which is just an array of strings. So what we can do is, as they join, we can do so elements. So size equals value. Okay. So we are now storing values given to our queue in something so we can return them. So what we can do now is we can return elements, and if we give size, that should work. Let's see. For some of our tests, I think that we shouldn't have broken any of our existing tests. We might not have yet fixed. Oh no. So yes, here we go. So now we've broken our we've broken our our tests that test the serving of a queue with more than one element in it. Okay, so size is not the right thing at this point. So we need to keep track of something else, because as we bring things off the queue, we are moving the point at the front of the queue. Now, the quickest way to do this at this point is we can keep track of the front. So private front equals 0. Int front equals 0. And then if we return front, I think we should be at a position now where we're back to one failing test. We are, and we're back to our, so we're back to, we expected blue, but we got red. So what we can do is we can do string element equals that front plus plus element. Okay, like so, and let's see if that works. It does. Okay, so we've now written enough functionality for our test to pass. Okay. So we're now on to our, we've completed kind of all of the happy path of the implementation of our queue. We know whether it's empty or not, we know the size, and we can serve people or elements that are in the queue. Okay, so one thing to note is we added the add function without ever directly testing it. We don't have a test for add, and that's because it doesn't have any behavior. It doesn't return anything. It doesn't do anything that you can assert on. So we haven't added any tests for the add function directly, because what we've done is we've tested and ensured the behavior that add has on other functions. So we changed add when we implemented the empty functions. We added a hard-coded, we added a field that we flipped the flag when we were doing empty, and then as we moved into testing the size, we kept track of the number of elements added by incrementing the size function. And that's really good to note, is that some functions will be added without a direct test. There's no need for a direct test if it doesn't have its own behavior, if its behavior affects other tests. Okay, so there we are. That's the happy path. That's of our queue implemented. Internally, we're using an array, and we've got all these things. Now, one of the refactorings I could do at this point would be to change using an array and keeping track of the size for a different data store we could use instead of an array, which could give us some of this functionality that we are adding to our queue, sorry. So we might not want to use an array. That would be a refactoring. We're only changing the internal understanding of the structure of a queue. We're not going to ever affect the implementation, the external implementation, by changing things internally, like tracking size or tracking number of elements. As long as all our tests pass, we can change the internal workings of the queue in any way we want. As I've said, we have completed the happy path of testing the queue. If you want, you could go and try doing that refactoring on this code once you finish watching this video. Or the other thing you could do is start looking at kind of some of the sad paths. So you could look at adding some tests or a test around what you can do to a queue if you try to add, so you try to serve an empty queue, and you need to make some behavioral decisions at this point of what do you do if you try to serve an empty queue. You could just return null, or you could throw an exception, and that's a decision that you need to make, what you prefer to do, and think about how you think other people need to use your queue. Do you just want to return null and they need to do a nullness check, or do you throw an exception and they need to catch or try catch every time they serve from the queue? Those are design decisions you could make as you add the tests. What you could also do if you wanted to continue playing with the queue is you could add a leave function, which would take a string and enable that element to leave the queue and remove that element from the queue, and ensure that the queue remains intact. So those are some things you could do if you want to continue working on this piece of code and have a play with some kind of test driving some things yourself. You could also maybe take this implementation, this style of implementation, and apply it to a different abstract data type. You could do a stack and add things to a stack and remove things from a stack. That might have a slightly simpler implementation because you're not having to keep track of the front and the back of the stack, because you're just adding things onto it and then taking them off the top. So you're only having to keep track of the size in that one. So you could have a play with both of those. I hope you found this video useful, and there'll be more Java videos coming in soon. Thanks for watching. Thank you for watching this episode of Testing All the Things. I hope you enjoyed it. If you did, please rate and review the video and subscribe to the channel. If you did not and you have any feedback, please leave a comment in the comment section of the video, or contact me on Twitter @Bradle.